Good morning. This is Trina here to discuss about thermodynamics. So in thermodynamics, it is the first lecture. So today I will discuss about different concepts like what is the system, what is the boundary, what is surrounding, and the different process, properties, etc. And if you have any doubt regarding my lecture, you can communicate through my mobile number or my email ID. So these are given in my personal information. And the most important part, that is the course page, I have uploaded entire study materials, all the probable questions, semester questions, and solve problems. So I hope you have already joined. So go through entire study materials. First of all, you have to join with this code. Then you can access all these study materials. The course chemistry, the subject code is CH101 for odd semester, CH201 for even semester. This course is for BTech undergraduate students and the streams are CSE, IT, Civil, Mechanical for even semester and Electrical, EC and BME for odd semester. The credits 3, contact hours 36, and I will take weekly 3 lectures, 3 classes. Prerequisite knowledge required to understand this concept is the 12th standard. And from this subject, that is the course objective, you will get the several concepts of chemistry. And in the outcome part, the students will be able to apply the fundamental concept of thermodynamics in different engineering application. So here also I have given the entire lecture plan. So from this you will get the idea that which topics will be covered in which day. So this one is part of the module 2. Here you can see this, it is the module 2, the use of free energy in chemical equilibrium. So today I will start, it is the already highlighted, you can see the basic concept of thermodynamics, system, process, properties. And students will be able to apply fundamental concepts of thermodynamics in different engineering fields. So now, first, can you tell that what do you understand by thermodynamics? What is thermodynamics? Can anybody tell? What is thermo and what is dynamic? So thermodynamics is the combination of 2 words. One is thermo, that means heat, and another is dynamics, that means motion or flow. So thermodynamics implies flow of heat and it deals with relationship between heat and work. That is very important for all field of engineering. So thermodynamics is defined as the branch of science that deals with the relationship between heat and other form of energy, such as work. It is frequently summarized as the 3 laws, first law, second law, third law, and also there is another law that is called 0th law. So one by one, I will describe all these things, that how the work, the energy and heat are interrelated, you will understand gradually. So today it is the first lecture. I will give the basic concept, the basic terms which will be required to understand the law of thermodynamics, like first law, second law, all these things. So first, one of the basic assumption of thermodynamics is the idea that we can arbitrarily divide the universe into a system and its surroundings. So what is the thermodynamic system? So we can define, how we can define, it is the part of universe. Thermodynamic system is a part of universe isolated from the rest of universe for investigation is termed as system. So we can consider a system in different way. Okay, so if we consider a small room, like in my room, that if we consider this is a system, then it is like boundary will be like our wall. Okay, if we consider my system is the total house, okay, then also we can consider, in this way also we can consider the system. System, so what is the system? It is the part of universe isolated from the rest of the universe for investigation. So when we will do the investigation, we will consider the which is the our system and which is the surrounding. Okay, so in this way we can define our system. So here you can see this is the system, this is our system, and this is the surrounding, this is the boundary. So system we can take in different way. As I told, we can take the small room, we can take the whole house, we can consider the city as our system. With respect to the rest of the universe, we can consider the total country with respect to the total universe. Okay, in this way, we can take different way of the system. And this is the boundary and this is the surrounding. If we consider that our body, it is a system, then we will consider the rest of the universe as our surrounding. So how it is we are taking the input and there is the output we have to consider for the consideration of the equilibrium or the system. So you understood this is the system, and what is the boundary? The rest of the universe is called as boundary. Sorry, rest of the universe is called as surrounding, and by which it is separated, that is called boundary. So everything external to the system is called the surroundings or environment. The system is separated from the surrounding by the system boundary wall partition. It can be real or imaginary, rigid or non-rigid, permeable or impermeable. So anything it may happen. So like a beaker, if we take a beaker, so beaker, the wall of the beaker, that is the boundary. So it is real. If we take the volume reactor, constant volume reactor, then the wall may be the boundary. Okay, you can understand. Now, this is the system classification. So system is of three types. That is the open system, first. Second one is the closed system, and third one is isolated system. So in the open system, what you can see, the heat is transferred and also the matter, that means mass, is transferred. That is called open system. So both heat and mass both are transferred. That is called open system. Now closed system, only heat can be transferred but mass transfer cannot take place. So matter cannot be transferred as it is the closed boundary. So in the closed system, only the energy can be transferred. Instead of heat, better we can say the energy can be transferred. It may be the vibration, it may be radiation, anything. And matter cannot be transferred. For the isolated system, so here you can see the isolation, that means there may be the insulation. So there is no transfer of heat and matter. So there is no transfer of energy and mass. Nothing can be transferred. That is called isolated system. This example is rare. So now, so you have understood that three types of system. One is open system, closed system, and isolated system. So here the same thing, it is written here, the different representation. Here it is the system, it is the surrounding. So isolated system means you will write that no exchange of matter, no exchange of heat. No exchange of matter and no exchange of heat. Here, the closed system, no exchange of matter, but can exchange heat energy. Here, the open system, the surrounding open system. So first one is isolated system. So no exchange of matter, no exchange of heat. Next is the closed system, no exchange of matter, can exchange heat energy. Open system that can exchange matter, can exchange heat energy. Okay, so both can be exchanged, both can be transferred. So I hope that you have understood very well the different types of system, open system, closed system, and isolated system. Now, you look at this example. Okay, in the open system, so in this conical, there is some solution. If you provide heat energy, then it will evaporate. So the liquid which is in the solution, that is going out. So that is the mass transfer. As well, there is the heat transfer. Here, there is the heat transfer. Heat transfer. So we can call there is both mass and energy transferred. So that is the open system. Now in the second one, closed system. So here is the closed boundary. So there is only heat transfer taking place. Okay, the energy transfer taking place, but no mass transferred as it is completely covered. Now, the third one, that is the isolated system. Isolated system, you can see there is the insulation. That is why there is no heat transfer, no mass transfer takes place. So that is the example of isolated system. Like say if you take a saucepan and you boil the water. So water and the container is open, it is not covered, then what will happen? The water vapor will go to the atmosphere. So it is the mass transfer. matter, transfer of the matter is taking place. So we can say this is the transfer of matter is taking place, as well heat energy is transferred. So it is the open system. Now, if you take the, that means a closed container, then you give the heat energy. So the heat energy can be transferred, but matter cannot transfer. So this is the example of closed system. So you have well understood that the open system and closed system. Next is the thermodynamic properties. So what are the, it is the macroscopic properties. We can divide in two categories. Number one, intensive properties. Number two, extensive properties. So what is the intensive properties? Intensive property is a physical property of a system that does not depend on the system size or amount of material in the system. Okay, so example is density, pressure, temperature. So it does not depend on the mass. Simply to say, this property does not depend on the mass. So it is called the intensive property. So if you take the example like say density. Density means mass by volume. Okay. So it does not depend on this matter. Temperature, it also does not depend. So they are the intensive properties. Next is the extensive properties. An extensive property of a system does depend on the system size or amount of material in the system. Like say volume, internal energy are the extensive property. So they depend on the amount of material. Like say amount of material increasing, so like volume increasing, like that. Okay, so it depends on the amount of material. So these are called extensive property. So the question may come like define intensive property, extensive property with example. And also it come like which of the following, like as example, that which of the following is intensive property. So there will be given like say temperature, volume, then say internal energy. So your answer will be the temperature. Temperature is the intensive property which does not depend on the matter, mass. Next is the thermodynamic process. So a thermodynamic process occurs when the system goes from some initial equilibrium state S1 to a new equilibrium state S2. The system coordinates, example like temperature, pressure, etc. So there are different thermodynamic processes. So here you look at the graphical representation. There is like Isochoric process, Isobaric process, Adiabatic process, isothermal process. So there are different processes in thermodynamics. So one by one, we will get the idea about different processes. So number one, the isothermal process. So from the name you can understand that what is the isothermal process? It occurs at constant temperature. That means thermal, isothermal, that means same. There is no change in the thermal, that means heat energy. Okay, so here if we represent mathematically, that will be dt is equal to 0. Okay, here it is the dt. That means the temperature will remain same. This is the process where temperature will remain same. As example would be a closed system immersed in an thermally connected with a large constant temperature bath. So energy gained by the system through work done on it is lost to the bath, so that the temperature remain constant. So there is no change in the temperature. So dT, the change in temperature, will be equal to 0. That is called isothermal process. Next is the adiabatic process. Adiabatic process. So adiabatic process is a process in which there is no matter or heat transfer, because a thermally insulating wall separates the system from its surrounding. For the process to be natural, either a work must be done on the system at a finite rate so that internal energy of the system increases. The entropy of the system increases even though it is thermally insulated, or the system must do work on the surroundings, so which then suffer increase of entropy as well as gaining energy from the system. So the representation of mathematical representation of adiabatic process, that dq is equal to 0. That means there is no heat transfer of heat energy. Next one is the isentropic process. So it is basically when the entropy remains same. That is the isoentropic process. So it is customarily defined as the idealized quasi-static irreversible adiabatic process. So you will learn gradually. So just remember iso plus entropic. So you will learn the entropy. When the entropy is same, there is no change in the entropy or randomness. That is called isentropic process. Okay, next is the isobaric process. So isobaric, iso means similar, there is no change, and isobaric, bar related with the pressure. So an isobaric process occurs at constant pressure. Okay, when the pressure remains same, that is the isobaric process. An example would be to have a movable piston in a cylinder, so that the pressure inside the cylinder is always at atmospheric pressure, although it is separated from the atmosphere. In other words, the system dynamically connected by a movable boundary. So here constant pressure, that means we can represent it by dP is equal to 0. Okay, you are clear? So iso means similar. So if it is isothermal, so the heat, that means temperature, will remain same. If it is isobaric, that means it is related with the pressure, so pressure will remain constant. If it is, say, isochoric, so what is isochoric process? So it is related with the volume, so volume will remain same. Okay, so isogoric process is one in which the volume is held constant, with the result that mechanical PV work done by the system will be 0. On the other hand, you can say the work can be done isochorically on the system. For example, by a shaft that drives a rotary paddle located inside the system. So for isochoric, what will happen? dV will be equal to 0. Okay, the expression will be the dV is equal to 0. this one. The change of volume will remain same. Next is a thermodynamic cycle, cyclic process. It is the cyclic process. So it is consists of linked sequence of thermodynamic process. So there will be different sequence, the stepwise thermodynamic process, and if it occurs cyclic way, and that is called the cyclic process. So in this process of passing through a cycle, the working fluid may convert heat from a warm source into the useful work and dispose of the remaining heat to a cold sink, thereby acting as heat engine. Okay, conversely, the converse of the heat engine, what we get, the cycle may be reversed and use the work to move heat from cold source and transfer to a warm sink. What is it? That is called heat pump. So we use that different, that is the heat engine we use the heat pump. So everywhere you will get the application of thermodynamics. Okay, if you consider our refrigerator, you will get the application of thermodynamics. So here the heat engine, so this follow a path, and if it complete the complete cycle, that is called cyclic process. At every point in the cycle, the system is in thermodynamic equilibrium. So the cycle is reversible. Its entropy change is zero, as entropy is a state function. Okay, so now what is the reversible process and what is the irreversible process? So for the cyclic process, what we can say, the expression we can say, the internal energy change, that is the zero, as it will come back at the, it will follow the path quantities, and that is why it will come to its initial state. So we get that dE is equal to 0. Okay, dE is equal to 0. The internal energy change is 0. So now, what is the reversible process and what is irreversible process? So in thermodynamics, a reversible process is a process whose direction can be returned to its original position by inducing infinitesimal changes, the small changes to some property of the system via its surroundings. And what is an irreversible process? So you got the reversible process, that is the reversible process, and now an irreversible process. So irreversible process that cannot return both the system and the surroundings to their original condition. That is, the system and the surroundings would not return to their original condition if the process was reversed. Okay, so it is the spontaneous process. It does not come back to its original process, or we have to do the extra work to make it reversible. So this is the irreversible process. So you have understood that what is reversible process and what is irreversible process. Okay, so if I summarize what you have learned today, number one, you have learned that what is thermodynamics, why it is so important in different engineering field, and also you have learned that what is the system, what is surrounding, what is the boundary. You have learned open system, closed system, and the isolated system, the three types of system. And also you have learned the different thermodynamic process like Isochoric process, Isobaric process. Iso means that there is no change. If it is thermal, isothermal process, there is no change in the temperature. If it is isobaric process, there is no change in the pressure. Okay, so this part you have learned very well. And also you have learned the macroscopic properties, that is the intensive properties and extensive properties. So I hope that you can answer my questions. So I have given the questions. Number 1, define open system, closed system and isolated system. So can you answer? What is your opinion? You have learned properly or not? Yes, yes. I hope that you are telling that yes. So you can define open system, closed system and isolated system. Second one, that describe different thermodynamic process. So different process like isochoric, isobaric, everything you can define. And also it can come in this way, that define isothermal process. Okay, then you can tell individually. Next is define extensive and intensive properties along with example. So you can tell that which depends on the, which does not depend on the matter, amount of matter, that is the intensive property, which depends on the amount of matter, that is the extensive property. And you can give the examples. Now, if I tell that distinguish between the reversible and irreversible process. So what you can write, I have given also here in your study material, that the reversible process, the number 1, the process is carried out infinitesimally slowly. That means it occurs very smallly with the very small steps, and it is carried out rapidly. At any stage, the equilibrium is not disturbed. Irreversible process, equilibrium may exist only after the completion of the process. Number 3, reversible process, it takes infinite time for completion. But irreversible process, it takes a finite time for completion. That means it occurs very rapidly, spontaneously. Number 4, work obtained in this process is maximum. And for irreversible process, work obtained in this process is not maximum. Okay, so you have learned the different process like reversible and irreversible process. Now, for today, I am ending the session. Thank you, everyone.